Alright guys, this is our final video for the astronomy unit. We have a few objectives here. We're going to talk about what a galaxy is, get into what a universe is, cosmology, asteroids and the asteroid belt, talk about what comets are and how they're related to meteors and meteorites and shooting stars, talk about what the sun is and how it's related to constellations. So let's jump right in. Okay, so here's our solar system, just as kind of a review. You should know all this stuff by now. The Jovian versus the terrestrial planets, the planets in order, the dwarf planets versus the planets, and the special properties of each one. Well, you also know that our solar system does act as a system. Everything is being held together by gravity. And if you remove one thing from the system, everything else will be messed up. Well, we're also a part of a larger system called a galaxy. Our solar system just has one star. Well, here's a galaxy. And our galaxy, a really good way to define this would be an island of hundreds of billions of stars. Just an incredible number of stars. For example, I couldn't draw one star on this galaxy here. In fact, these little tiny white clusters that you see here, these little dots right here, this isn't one star. These are millions of stars in each one of these little clusters. So it would really be impossible for me to represent just one single star on here. And our solar system is just a small part of this entire system of a galaxy that's just absolutely huge. How big? If you were to travel from here to here, for example, it would take you hundreds of thousands of years if you were traveling the speed of light, going 186,000 miles per second. These things are absolutely huge. And if you're sitting here and you're a little confused because you can't comprehend how big this is, you're not alone. One thing to just note here is that a galaxy is an island of hundreds of billions of stars. And just to kind of drive you crazy a little bit, each one of the stars that are in this galaxy here has the potential to have planets going around it, multiple planets going around it. So think about how many planets there must be in one single galaxy alone. Well, if that's not enough to drive you crazy, there's more than one galaxy out there. We'll get to that in a second. Here's a picture of a part of our own galaxy. It's called the Milky Way galaxy, and that's something that you should know. The name of our own galaxy is called the Milky Way galaxy. This guy right down here. The Milky Way galaxy. That's the name of ours. Now, when we take a look at this picture and we see this band of stars in the sky, this isn't our whole galaxy. We can't travel out of our own solar system. We can't pull back far enough to get a whole picture of our entire galaxy. This is just a dense region of our galaxy. So we're looking at a very highly populated area of our galaxy that would have a lot of stars. Normally you'd be able to see this here from Palatine, but we have too many lights. So you got to get away from those lights, go up to Wisconsin. You'll see this pretty easily, or even down in southern Illinois. Well, not to drive you crazy or anything, but every dot in this picture is a galaxy. Our universe is made of billions and billions of galaxies, each containing hundreds of billions of stars. The numbers just become mind-numbing. So it's really difficult for me to explain to you how many galaxies are out there and how big they are, because I don't have a firm comprehension of it. I really don't think anybody can picture how big it is because we have nothing to compare it to. We don't really have anything for scale. But what we should know is that all these galaxies together, and these are just a very small amount of galaxies in the entire universe. This is not a real picture of our universe. This is an artist's rendition of what our universe would look like. And if you were to picture each one of these little tiny dots, each one of these little pixels in here, would be a grouping of galaxies like this. There'd be billions and billions of galaxies throughout the entire universe. So what is the universe? How do they define it? Well, the observable universe is all matter and energy that can be seen and detected. Not just with our eyes, but also with telescopes. The universe is everything. We have limits to what we can see. The universe is simply all matter and energy. This is the stuff that can be seen and the stuff that can't be seen. So there's the difference. The observable universe is everything that we can see and detect. The universe is everything that's out there. So who studies this stuff? It's up to cosmologists. Cosmologists, not cosmetologists. Those are the guys that study makeup and stuff like that. Cosmology is the study of where everything's come from and where it may be going to. What I mean by that, here's what they may study. A cosmologist may study the age of the universe. They estimate the age of the universe to be about 14 to 18 billion years old. It's pretty old. They look at the size of the universe. They also may take a look at the origin of the universe. Cosmologists call this the Big Bang. They call this the start of the universe. They call it the Big Bang. It's an event which began the entire universe. That's what they believe in. They believe that all matter and energy was contained into a small little mass, maybe a ball like this, and that it all exploded outward in one big, huge cataclysmic explosion, and it expanded and made space and everything else that's around us. All right, let's move on to something different. Let's talk about the asteroid belt. The asteroid belt is a band of rocks that orbits in between Mars and Jupiter. Here's your definition. They're small rocky objects that revolve around the sun between the inner and the outer planets. And again, the inner planets there would be the last inner planet would be Mars, and then the outer planet would be Jupiter. Here's an important note about asteroids, is that they are not round. They're kind of shaped like potatoes. And that way they can't be planets or dwarf planets, because if you remember, planets and dwarf planets have to be round. So none of these guys can be round. And that's what an asteroid is. There are lots of them. There's about 100,000 of them or so. When we take a look at this picture, it's kind of fake because it shows way more than 100,000. There's a lot more space in between the asteroids than this picture shows. Here's what a comet is. It's a chunk of frozen gases and ice and bits of rock that orbit the sun. One thing to note about comets is that they all have tails. And again, these tails are made mostly of frozen gases and ice and bits of rock. That's what the tails are made out of. Another cool thing about these is that they have really huge orbits. And what I mean by that is this. Let's let this circle be the orbits of all the planets around the sun. So this circle is all the planets: Mercury, Venus, Earth, Jupiter, Uranus, Neptune, Pluto, Aries, Ceres, all the planets and dwarf planets. Well, here's how a comet orbits. A comet will whip around the sun, go way past it, and come all the way back around. And these orbits can take hundreds of years. Some can take over 1,000 years. So they have really huge orbits. Another thing to note is this, is that when a comet passes by, it leaves a lot of debris behind when the tail is kind of flaking off the rest of the comet. And yes, the comet does get smaller the more it travels. But check this out. If Earth in its revolution passes through the tail of the comet, we're going to get little bits of this stuff that burn up in our atmosphere. And here's what it looks like. They produce meteor showers. And that's what this is here. We have a meteor here. And all meteors are rocks from the tail of a comet that are burning in our atmosphere. And a meteorite is one that's crashed to Earth. I like this picture here. This is a little this is here in Chicago. This happened a few years ago. There's two pictures here. There's this inside picture here, and then there's this outside. A meteor from the tail of a comet crashed right through this dude's apartment. This is the ceiling right here, and it crashed. Here's the comet. I'm sorry, not the comet. There's the meteorite right there that crashed through the guy's ceiling, smashed and broke up his computer or whatever this is. Here's his file cabinet. This is a real picture. You can look it up. This is in the early 90s here in Chicago when a meteorite crashed down through some guy's apartment. So again, here we have meteorites that are debris from the tail of a comet, or meteors from the tail of a comet that are burning up in our atmosphere, and a meteorite is one that has crashed down to Earth. Now, these meteors that are burning up in Earth's atmosphere have another name. They're called shooting stars. These are not stars. And what we're looking at is we're looking at this streak of light right here across the sky. These are meteors that are burning up in Earth's atmosphere. So shooting stars, it's false. They are not stars. They are burning meteors or debris that are crashing through Earth's atmosphere. All right, we're almost done. Let's talk about the sun. The sun is an average star. It's average in size, it's average in mass, it's average in temperature. So it is an average star compared to all the other stars out there in the universe. It is not special in any way, shape, or form other than it gives us heat and light from the sun. Because it's average, we use it as a model for all the stars. It's the star we know the best about, the most about, because we live really close to it and we can study it easier. It gets all of its heat and light, just like any other star, through nuclear reaction, specifically nuclear fusion. When you take chemistry, you'll understand this a little bit more, and then we'll talk about it more when you take astronomy a couple years from now. But nuclear reactions or nuclear fusion give the sun all of its heat and light. And then lastly, we have constellations. And constellations are patterns in the stars. Patterns of stars. And here's a pretty famous one. Here's Orion. There's a little figure of a hunter right here. Got this guy here. Here's his belt. And if you picture, like, here's his head right here. He's got his arms coming out. He's holding a shield over here. He's got legs that come off down here somewheres. So there's a figure of a guy. This is Orion. And that's patterns of stars. There's 88 constellations. 88 official constellations in the nighttime sky, or patterns of stars. And another thing to note here is all the stars in this picture, every single one of them, they all get their heat from nuclear fusion just like our sun. And everything we know about all these stars, we learn by studying our sun, our average star. Okay, so we talked about what a galaxy is, the universe, cosmology, asteroids, asteroid belt, comets, meteors, meteorites, shooting stars, the sun, and constellations. As always, if you have any questions, feel free to go back, rewind, clarify the information. You can Edmodo me with any questions or just ask me in class tomorrow.